differentiated with respect to a is the same with 2n times a. A number times a prime is that number.
Oh, the product rule. Okay.
No, it's not the product rule. So I rearrange them in a different order just for you to understand that this is a number in front of a. So when I differentiate 5a prime, I get 5. When I differentiate blah, blah, blah a prime, I get this. Is that better?
Okay. I guess.
So when I differentiate this with respect to a, I am left with 2n.
I think it makes sense.
Because a prime is 1. But now if I have, for example, 2a squared n prime, this, I shouldn't write it like this because it's a partial, right? But to explain, then I will have 4an because I'm differentiating this to get 2a times 2 will be 4, and then n has to stay. Is that better?
Yeah, I think so.
Okay. So which one would we like to eliminate? Do we want to eliminate a or n? It doesn't matter. So let's eliminate. Sorry, go ahead. You want to eliminate a. Good. So then the first equation is still that. And now when I multiply both sides by 5, I get 10a minus 30n. 2a times 5 is 10a. Negative 6 times 5 is negative 30n equals 20.
Sorry, Professor Lee. Where did that 5 come from?
So if we want to eliminate a, we need to multiply the entire equation by 5. So then I have negative 10a and positive 10a to eliminate a.
All right. Okay. Thank you.
Right? Okay. So then I can add them term by term. And negative 30 plus 2 is negative 28n. And negative 48 plus 20 is negative 28. Awesome. So then n equals 1. Then I go back with n equals 1. So I have 2a minus 6 equals 4. Or 2a equals 10, or a equals 5. Now you have to be super careful because we have to write an ordered pair. And don't just pick and choose. It's a comma n, not n comma a. So a comma n, a comma n, 5 comma 1. Okay. Then, so that was step 1, and step 2 I determined, I solved it in step 3. Okay, step 3 I solved the system, so I got 5 comma 1. Yes, it's always safe to go back and check. 5 comma 1, 5 1, 5 1. Negative 50 plus 2, negative 48. Check. 10 minus 6, 4. Check. So then I know 5 comma 1 is correct. In step 1, I determined the partial derivative with respect to a and the partial derivative with respect to n. Then I set them equal to 0. I already moved terms around. Then I solve the system in step 3. In step 4, I have to determine the d-test for 5 comma 1, which is fxx at 5 comma 1, evaluated at 5 comma 1, times fyy evaluated at 5 comma 1, and minus fxy evaluated at 5 comma 1, which is also squared. But I don't have these yet. Let's determine them. So, good. So fxx, fyy, and fxy. Now let's go back. Oh, you know what I meant. I meant P. PAA, PNN, PAN. Okay, so PAA, I already have this differentiated with respect to A. These are gone because they don't have A in them. So this is negative 10. Now PNN, these are gone, negative 6. And now PA with respect to N, PA with respect to N is just 2. These are gone. N is only here. So when I differentiate this with respect to N, I get 2. Okay. Nice. So now the 5, 1. So D at 5, 1 will be PAA, negative 10, times PYY or PNN, negative 6. So this is multiplied, minus this squared. So this is 60 minus 4. And 60 minus 4, I don't care about the number. It's a number greater than 0. Going back to what the test says, if D is indeed greater than 0, now I'm looking at fxx only. So this is my fxx. And it's negative. So 5, 1 is a relative max. So I'll write here PAA at 5, 1 is a negative. So therefore, from these two, D is positive and fx, or PAA in this case, is negative. Then we know that 5, 1 gives a relative max. But what is the relative max? I don't know. I have to find P, not PAA of 5, 1, but P, the function at 5, 1. Okay, I have to go back here. So I have negative 5 times 25 minus 3 times 1 squared, which is 1, plus 48 times 5, and minus 4 times 1, which is 4, and plus 2an, so 10, and plus 290. So is it this real quick thing? It's easier if I just do this. So negative 125, and then minus 3 and plus 48 times 5, and minus 4, and then plus 300. I got 408. So this is 408. And did they tell us what is the measurement unit? What did they say P was? In millions, yes. I wrote it down on 3 pages ago. So this is in millions. And this is very clear, I hope, when it comes to finding a max min for a function of 2 variables. Obviously, what we need to do is the d-test. And compare. If D is positive, then I look at these two and make the conclusion. If D is negative, no max min. If D is 0, test is not applicable. How do you feel about this section now?
Needs practice.
Yes, I agree. Now, can we go back and talk about other things, or you still want to work on another problem, or is this okay for now?
One question.
Yes.
Just,
Yes.
I'm sorry. I guess I missed it. Why 60 minus 4 is greater than 0 than P5, 1 is less than 0? I didn't get that part.
This is PAA at 5, 1.
Oh. Okay.
So once I determine D, I only look at this number, the first in the product.
Okay. Okay.
And since it's -10, it's less than 0.
Okay. Yeah.
No, but you're right. You're right. Let me write it here so you know where it's coming from.
Thank you.
Sure, of course. Okay, so do we have other questions? Do we still want to see another example like this? They're all the same, but it doesn't matter to me. Or we can go to other word problems to clarify what the problem is asking and how to categorize it.
I don't know what my classmates think, but I think we can, we can always watch your video for this one. And if we have questions on Monday, office hours, we can ask them.
Sure.
But it's better to use our time to do,
So let's look at word problems.
We should review.
Okay.
Yeah.
Very good. So in chapter 6, so let's start going backwards. It's very clear when a problem is asking us to find max min, and the problem is giving us a function with 2 variables. That's the D test. Is that clear? Another one is if I'm given a table with ordered pairs x, y, and I'm asked to find the linear regression. It's very clear, right? You have to put the x and y in the table, and you have to determine the linear regression. Is this clear? Do we need an example from this? We did this last time.
I think that's clear.
Say it again.
I think that's clear.
Okay. And we know how to calculate everything in the calculator, yes?
Yeah, that one's just all calculator, right?
All calculator. But when it says linear regression, there is no confusion. That's what I want to make sure that we understand what needs to be done. When it says linear regression, we understand what it needs to be done, correct? Yes?
Yes.
Okay.
Yes.
Now, still in chapter 6, what if I'm given something like, let me go back and just show this. I'm going back. So we discussed 6.4, we discussed 6.3, what type of word problems we can encounter there. I just want to go back to 567. 567. And see what type of question I may have here. We did not do any specific type of problem here. We only learned how to differentiate and find partial derivatives. So nothing from here. And in the first section, which is on page 557, we only can be asked to evaluate. So we will be given a function and domain, of course. So here, domain. We may be given a function and evaluate it. Nothing else. There is nothing, no other word problem from 6.1. So I may be given this, and I'm asked to plug in P, L, V, R, and R and get a number. Be careful how you plug them in, right? When, for example, here it's very clear. They are telling us exactly what we need to do. Find V of 1, comma, 100, comma, 0.0075, comma, 0.0025, comma, 0.005. Just carefully plug them in. And this is the end of chapter 6. So let's look at word problems from chapter 5. We only have 2 sections. One of them, I think it's very clear. So let me let me go back to 5.1, which is page, what I'm looking here. Where is 5.1? Page 480. 480. So I think that this is super clear because this is the consumer surplus and producer surplus. You can't miss this one, right? It's very specific. You are asked to find two integrals, right?
Yeah.
So this is again in chapter 5. So let me write this here. Chapter 5, consumer surplus plus producer surplus. There is no ambiguity there. Now let's look at 5.7, which is 535. In 5.7, we had problems. There were problems because we are focusing right now on word problems. We had this problem that we worked on together. So all I can be asked is, I'm given something like this and I'm asked to find the function. So that will be very clear because it says, so I'm given dv over dt. So I'm given dv over dt and two variables, L and V. So obviously this is very clear. Why I would say it's very clear, it's because I'm given a differential equation. So once I'm given a differential equation, this is a differential equation, this is a differential equation, this is a differential equation. So I know that this has to come from 5.7, in which I integrate both sides. So differential equation. Now, when it comes to chapter 4, the end of chapter 4, because we were going backwards. So from 4.5, substitution, what word problem? So 435. 435.